Hello everyone. Today I'll show the solutions to problems 5 and 6 of round 157 of the Prairie Math League. So for problem number 5, we have a unit square, unit meaning all the sides are 1, and we draw equilateral triangles on all of its sides. And then we draw 8 more triangles in total, one from each side of the new equilateral triangles. And these all, since these are all equilateral and the square has side lengths 1, these are all, these equilateral triangles all have side lengths 1. Yeah, you get the idea. Now let R be the region formed by the union of the square and all of the triangles. So basically, like all these triangles and this square, you just union them. So you take their total thing. So like this part. And as we can see here, yeah, we get something that looks like this. And let S be the smallest convex polygon that contains R. So on top of this, we have this part. Kind of forms an octagon. What is the area of the region that is inside S but outside R? So we have these. As we see here, the convex polygon contains this part, and so does the union of the triangle and the square. But the part that's in S but not in R is the part that's shaded in blue, the part that we just added with the addition of the octagon. Now, we're going to focus on a small slice here because it's much easier to find the area of the blue regions if we focus on this square. So, now first note that this is an equilateral triangle. So this height, if you could recall from a 30, 60, 90 triangle, if the hypotenuse is 1, then the height is square root of 3 over 2, and the base is 1 over 2. Now, this is also a slice of an equilateral triangle. So this is going to be square root of 3 over 2, and this is 1 over 2. And from a symmetry argument, we can see that this is also this is also square root of 3 over 2. And this works out because this is a square. Now, we're going to try to find the area of this one blue triangle. To do that, we also find this length, which we find to be square root of 3 over 2 minus 1 over 2, or square root of 3 minus 1 over 2. And this is also equal to this. Now, the area of the blue triangle here is equal to the area of the entire square here, minus the area of the white triangle, and the both white triangles, and then minus the area of the yellow triangle. Now, by base times height divided by 2, we have for the triangles, base times height divided by 2 for the white triangles, but you multiply by 2 because there's 2 of them that are identical. And finally, we also have the yellow triangle here. Base times height, base is equal to height. And finally, for the entire square, it's just square root of 3 over 2 squared, because definition of a square is area. Then we can expand all this, and we get this, or this, if we simplify. Now, we have 4 of these blue regions, and they're all the same. So we just multiply them by 4 to get to the total area that is blue, or the total area that's in S but not in R, to be 4 times 1 over 4, which equals 1, which is option choice C. Now we go on to number 6. A group of 12 pirates agreed to divide a treasure chest of gold coins among themselves. The first pirate only takes like a 12th of the coins. They're getting like completely ripped off, but whatever. The second takes 2/12 of the remaining. So, and it kind of continues. I don't exactly know how it looks, but the point is, after every iteration, the Kth pirate takes 12 of the coins that remains in the chest. Now, the number of coins initially in the chest is the smallest, for which this arrangement will allow each pirate to receive a positive whole number of coins. In other words, if there are n coins initially, then we're going to define n to be the number of initial coins. But basically, this statement is equivalent to there being an initial number of coins in the chest right after after each pirate takes their coins. So we now model the problem. So the first pirate takes 1/12 of the coins. So he takes n/12 of the coins, and this amount of coins remains. Notice that this is 1 minus 1 over 12. Now, so n times 11 over 12 coins remains for the first pirate. For the second pirate, they take 2/12 of the coins. So among the coins that remained from the first round, now there also remains 10/12 of the coin. Now this continues, and we basically get n times 11/12 times 10/12 times 9/12 all the way down to, for the kth pirate, 12 minus k/12 because they took k/12ths of the coins. Now, this gets like a bunch of numbers that all have to be integers, but I'm going to claim that this is the only number that from 11/12, 10/12, 9/12, 8/12, all the way to 1/12. This one number is the only number that we require to be an integer. Now, why is this? Well, first of all, notice that this part, like the denominator, contains a lot of powers of 2s and 3s. And the numerator will not be able to balance that even with 2 to the power of 3 here, because every time 12, like 12 will add 2 powers of 2 and 1 power of 3, and the numerator won't be able to catch up with that and balance them out. So the denominator is going to keep on growing, and the numerator is going to do nothing to, or it's going to do some things to try to stop the denominator from growing, but ultimately the greatest denominator that occurs in this one number. And you can see this for yourself just by like comparing this with like a number, like say up to here, 11/12, 10/12, 9/12, 8/12 times n, and seeing that this indeed has a greater numerator and a greater denominator, and so will require n to be greater. Now, what is this number exactly? This is 11 factorial divided by 12 to the 11, because this is like right before the last pirate takes the remaining coins. In other words, the number of coins that remains after the 11th pirate. So now we can evaluate this to be this. Just write down, for this one, you write down 11 factorial, prime factorize each of the factors, and multiply the prime factors together to get this. For the denominator, you do 12 to the 11 because 12 is equal to 2 squared times 3. And you raise that to the power of 11. Now, you get this after canceling a lot of factors, and therefore, since this is 7, this is 14, so 2 to the 14 times 3 to the 7 is the minimum value of n. Therefore, the 12th pirate takes this amount times n, which is this, and these cancel out, so we get this, which is 1925, and this is option choice B, and we're done. Thank you for watching.